All right, we're starting here our first session of storage therapy series. Okay, so session one, why nobody touches storage in production. Okay, so I'm Pedro Alpis. I'm Cloud Solutions and Tom Heads here in RealCloud, and I'm with Ryan. Ryan is the therapist. Please, Ryan, introduce yourself.
Hi, Pedro. Hi, everybody. I'm Ryan Sayre. I'm the field CTO for a company called Datafy. Previously, I served 5 years at AWS as a global storage specialist. And then prior to that, I worked for a number of storage companies. I've worked in animation. I've worked in high-tech semiconductors and even insurance.
Okay, that's a nice background. I'm happy to partner with Datafy. We're here from from RealCloud side. So let's start the session. We've seen here in RealCloud with a lot of prospects and also customers that they already are in the path to do some work in optimizing compute layer in clouds, right? This is like a layer that's already moving on. We have some players doing work inside that field. But on storage, we feel like the storage is a little bit different, right? And why is that, right? So why is data storage often untouchable?
Yeah, it's a tricky subject. It requires some deep therapy, and I'm glad to help. Uh, for a long time, compute was quite simple. When computers started, you had a computer operator, and then it started to evolve. As computers themselves evolved to different functions, whether it be technical computing, enterprise computing, creative computing, we started to create silos for our responsibilities. And with those silos, kind of had an understanding of who was in control of what. So by the time the 1990s and the 2000s came about, we had specific roles. You had a database administrator who was building the database optimized for that business function that the database served. You also had a storage administrator. And the storage administrator would frequently just see the database administrator and some other key application users as their key client. And so they were making sure that the performance was there. And then you had the users. And the users had demands of building the application better, more interesting, more aligned to the business that they were actually functioning in. But things started to evolve. We started to use the cloud. And we started out with the cloud saying, okay, just experiment. And then if that's experiment successful, we'll bring it back into our infrastructure. And that experiment ended up being such a success that people realized, hey, why are we managing all of this legacy infrastructure? Why don't we just provision things very simply and easily in the cloud? But what that lent itself to is a blurring of responsibilities, a blurring of kind of the knowledge on how infrastructure interacts with applications and its users. And then data storage kind of became this thing where, do we leave our architectures alone? Do we leave our do we refactor just a little bit? Or do we evolve to the cloud and take advantage of the latest technologies? And so in that confusion, we still need to keep the lights on. We still need to keep our organizations safe and running effectively. So many times we just say, okay, is it working? Don't touch it.
Yeah, leave it as it is.
Yeah, it's that don't touch thing that can kind of be an expensive bill in the end because we didn't touch it.
Yeah, that's a nice perspective. And talking about clouds, I mean, you can use storage in different ways inside the cloud, right? But and how can a customer choose what's the best storage flavor, right?
Yeah, it's a huge thing. There's really in storage overall, especially in the cloud, there's 3 types of storage. There's block, file, and object. And I'll be very oversimplistic with block. Block is the most fundamental component of all of the storage. In fact, everything from your phones to if you have a digital watch or anything like that, that has a little bit of block storage that boots the operating system and runs the local code. And block is not going away for a long time because you need to have storage that's close to compute so you can compute. So block is here to stay, but the way that we use it is evolving. The second category is file. And file is really, you have a file system, but it's the multiple user file access, this unstructured data that kind of enforces a hierarchy, but allows you to collaborate, at least locally, with other computers on the network. And that's fine. But we've kind of evolved into the third category, which is object. An object's also unstructured, but object can, if you want a hierarchy, you can create a hierarchy just by using tags and metadata. You don't necessarily have to create a folder where you're copying everything. You can just point to these objects. And so you can think of object as this massive sprawl, the data lake. So what I see is actually block and object growing. Object will continue to grow because no one wants to delete anything anymore, but block staying because we want to have that persistence, we want that performance, and we want that locality to compute so that we can have our applications that are fast and our transactions that are going quite quickly. It's going to be a mix, and we'll be evolving continually. And so if you have a database, you're probably not going to be refactoring or reinventing those data structures immediately. You're going to want to use block storage. If you're using if you're a broadcaster or some other media company and you have a lot of video that you need stored, you're probably going to be using object. And if you're a scientist and you have a group of supercomputers that you need to exchange a very rigid hierarchy of data, or you're in the oil and gas industry and you're processing different geotechnical data, you're probably going to use file. So any sophisticated organization's going to have all 3, but depending on the weight of your business process, you're going to have probably a heavy use of 2 and maybe even just 1. And that's what I've seen with my users when I was at AWS.
All right. And you could say like that most of the customers, if not all of them, use S3 today, right? But today we see that you already have some sort of options. I mean, to kind of optimize S3, you have like tiering offerings. You can use intelligent steering to do that in a sense, right?
Yeah, absolutely. There's so many different ways that you can be able to use S3, and there are more performant options for S3 now than there ever have been. You can use your S3s for backups, you use Glacier, you can have a whole life cycle of data on S3, and that's partly because you can treat objects with various policies. With block storage, it gets a little trickier. And so you need a little bit more nuance or a little more help. And that's where sometimes the complications can factor in, but that's what we're all here for, is being able to help out.
Yeah, and block storage also is something that every customer uses today, right? Because as you mentioned, I mean it's already been born with EC2, right? So basically can't use EC2 without block storage.
Exactly. The way that I describe it is it's EC2's hard drive. And there are many services that are managed services that you will use that behind the scenes, it's EBS. And so it's hard to get away from the fundamental blocks, so no pun intended, of EBS in AWS. But it's good to know where your data is landing so you can be able to choose and optimize and get the most out of each of the services that are offered.
All right. I think that leads us to the next nuance, that is, okay, I mean, so what are the risks that you might consider when we're talking about block storage in production, right?
Yeah.
Because I
Everybody,
don't feel like there are many options to handle that.
yeah. And many times, let's say you've moved a workload to the cloud. If it's working good enough, what's the incentive to make it better? There are many times that I went to users and I would say, hey, you're using an old EBS volume type like GP2. I'd say, you know what? You can move to GP3. You can do it seamlessly. There's no downtime. Do you want to save 20% on your bill? And users might go, well, it's not broken, so I don't think I'm going to change. And some of these users, they could be saving millions, but because they're so averse to change, because the perception and the mantra has been reiterated, any change is going to require downtime. Any change is going to be a disruption. And that's not really the case. In fact, that's if you know the tools and the systems that you're dealing with, there's a lot of easy ways that you can do modifications, but you have to do it safely. And it requires a little bit more trust and understanding of the subsystems before you do that. That's kind of where, so I'm former AWS, and that's one of the reasons why I actually joined Datafy, is because the engineers that built the highest performance volume type in AWS for EBS called IO2 Block Express, they actually started Datafy. And before that, they used to work for storage array companies. So they know that critically, there are so many different ways that data could disappear or be corrupted or do different things. And they've already built for that. So that is what actually earned trust for me to join Datafy. And it should earn trust for users as well, because they realize, okay, it's not like we have a pie in the sky idea that, wouldn't it be great if we could do all these wonderful things with storage? It actually comes from experience. And so I think that actually decreases the risk when you actually know that there are people with dozens and dozens of patents in their names specific to storage and cloud storage, being able to build a new product like this.
Okay, and you feel like there today, I understand that the central feeling is fear, right? To touch block storage, but the teams do modify today, right?
Absolutely. In fact, it's a great point. When users saw other organizations being able to move from GP2 to GP3 in a couple of weeks, and then they're saving hundreds of thousands of dollars on their AWS bill, they realized, okay, we can go into the pool, the water is fine. So being able to do, I would say, medium modifications. So like my file system stays the same, but I can go from a different volume type without issue. That earned a lot of trust in Amazon speak. So being able to expand the volumes, that's also another thing that people go, okay, this is no problem. And being able to do these modifications as part of the infrastructure while the application is running, it's been proven out. And that's an important aspect. So people are starting to get some comfort in making modifications, but only after seeing other users having gone through it prior to them. They don't want to be the experiment that's out there.
Yeah, that makes sense. And how can I balance right these risks and rewards of modernizing storage?
Yeah, it's a really good question. Many times we as users, we kind of fall into different categories. We might be an application owner, we might be a business owner, we might be an infrastructure owner, or even a performance focused infrastructure, application tester. There could be a blending of responsibilities, but we'll see a lot of push and pull. Do we want to keep the lights on? Do we want to optimize for efficiency or reliability? And it's hitting that sweet spot of efficiency and performance and reliability that we need to be able to skate to. We need to go to that space. And so I think the first part is getting familiar with what an infrastructure is already capable of. So moving from GP2 to GP3, you will save money. If you have GP2, you go to GP3 and you will save the money. It is the new default for all Amazon Linux instances. So why wouldn't you go and modernize? If you're using IO1, for example, you go to IO2 and you get 100 times more durability as well as lower latency for equal or lower cost. So there's all these things that should push you towards a better world because there are better products that are out there that don't require any interruption. Then you can start to evaluate other ideas. For example, if you're a database user, many database backup and recovery mechanisms cut out the middleman of the file system, and you can go straight to backup to S3. So if you want to use Barman or PG Backrest or Databaseus, you can have a very efficient application-centric backup that you don't have to coordinate with your file system. That's a great way of being able to manage your disaster recovery method. You can lower the cost, and it doesn't change the way that you're actually operating your database and your applications, because it's for disaster recovery and safety. And then finally, I talk about this automatic expansion of volumes. The seasonality of that. Let's say it's Black Friday and everybody's clicked on the retail database and it's grown, and then it's January 3rd and everything's quiet, but you realize your volumes have grown by 50% or more. There's a hangover associated with that. And historically, you'd say, well, maybe somebody else pays the bill, so I don't have to worry about that.
Yeah. Let's with the FinOps team.
Maybe the FinOps team actually doesn't even know. They just see the bill's gotten bigger and they realize, okay, well, no one deletes anything in storage in these modern days, so that's just the price of business. But it's not. This is a better way of doing it. And being able to do things like shrink without downtime, without having to copy data back and forth and have this really painful ritual of having to migrate even within your own cloud, that's kind of old news. And so that's the future that we look forward to. And maybe we'll talk about that some other time.
Okay. Yeah, I feel like that's, when analyzing EBS volumes, we hear that a lot of FinOps teams do, this work of analyzing unattached volumes and then, get in touch with the storage teams to understand if the volume is idle or will be utilized at some point. But I think that shrinking the volumes is still something that the teams have some fear, to walk into this subject. And because, the aspects that you've mentioned, fear of data loss, fear of downtime. So
that's why what's really interesting is the users that came from on-prem, they were used to all sorts of storage efficiency features like deduplication, and compression and thin provisioning. And so I always get excited because they've gone through that journey of efficiency on-prem. And what Datafy offers is thin reprovisioning. So it's basically thin provisioning in place without downtime. And that's been a really exciting thing to actually show that and demonstrate that, because people get those concepts on-prem and it's completely unfair that we don't have those options in the cloud. Well, today we do. So that's why we're excited to show a more efficient future and help save the planet one unused byte at a time.
All right. And I think fear is related with, a lot of these sub items that we've talked. But how can we reconcile, the business drivers, business side is saying, hey, you need to cut costs, you need to be more efficient.
Yeah.
Against the operational requirements that's, engineers need to maintain stability of the environment, availability, avoid downtime, avoid issues.
There's so many pressure points that we've talked about, and really it boils down to, is it possible to get better functionality and have a lower cost? And so when we see the evolution, say on the compute side, from x86 to Graviton, there's a lot of compelling reasons to move from an older version of an x86 architecture to Graviton, to get more performance, to get more capability, and have a lower price per hour or per unit of commitment that you've made. And so I think on the compute side, totally makes sense. And on the storage side too, if you can be able to say, hey, here I get my 3,000 free IOPS in GP3, where I had to pay for an over provision on GP2 to get that much, and I'm paying less. When it's both, that's when you can reconcile and it's no problem. So when we come to a user and they realize, here's a chance to actually drive performance and be able to drive efficiency, it becomes a how do we do this? And when we can demonstrate, here's how we install, here's how we reconcile, and hey, wait a second, the database has not even stopped running, or any of my Kubernetes workflows, they are still existing without any calls from the application owners saying, hey, why is my performance tanked? That's when it works so well. So I think that being able to do any kind of demonstration where you don't pause, you're not copying, basically anything smooth. And this is in regards to anything that's in the cloud, where if you can preserve that business continuity, it means that you get your weekends back. You can actually be somebody who can make changes during normal hours, rather than having to wait, hope that no one is making a transaction on a Sunday morning at 3 a.m. while you restart the database after you've done your copy. I think that those days, they're kind of over with, and we have a lot more offerings today. So I think that's it's really important to have both a performance and capability advantage, as well as be able to justify, hey, here's where we can do more with less. So really show me the money with some features thrown in there.
Yeah, I think that every team which search for this oasis, right? That you can do these types of changes in real time. No need to specify specifically maintenance window to do the changes, and afterwards you don't touch storage anymore. Only the next day, right? I think that's what everyone is searching for, right? To be able to...
one final thing is, so Amazonians talk about this idea of a one-way door and a two-way door. And what a one-way door is really when you go through that door, you can't go back. So whereas a two-way door, you can always go back and revert to the configuration. And I think that that's important with any architecture, whether it be from going from x86 to Graviton or you using Datafy EBS Autoscaler or being able to uninstall it, being able to go back to the way that it was also kind of turns life into a more kind of iterative process. And if we make a mistake, so to speak, or we have a hangover or any of those things, we can undo it and we're always back to normal. So the good old days might always not be the good old days, but at least we can go back to a known good configuration. And I think that that's always important as we continue to improve ourselves.
Yeah, I agree 100%. I feel like this is a question that's every single customer asks. I mean, when analyzing a new platform technology or SaaS, is, hey, okay, very nice tool, but how can I roll back that? If I want to quit, what is the process of quitting, right?
Yeah.
For whatever reason, right? I mean, can even be like, hey, I'm transitioning back to on-prem. I don't know.
We're not going to
different clouds.
Yeah, we have the ability to retain our identity. We will not lose ourselves to the system that we're maintaining.
Okay.
Yeah,
I think that was a great first session. I mean, it's you brought the lights about a lot of subjects that I think that many many engineers, many storage teams are never thought about it. Maybe, I don't know, maybe they thought about it but they never seen or heard this approach, so we will need more sessions to dig in to understand the magic, right?
yeah. I think that part of it is people want the relevant conversation in their domain, and this is it. So it's good.
Okay, so thank you, Ryan. We're in this session, and folks that are watching, you can get in touch to the QR codes, and we see you next rounds.
Thank you, everybody. Thank you, Pedro.
Obrigado.
Obrigado.